Imagine trying to build a civilization without the number 0. Number 10. Number 100. No millions or billions. You could count 1 sheep, 2 sheep, 10 soldiers. But how would you write 101 without a 0 in the middle? No modern banking. No algebra. No computers. Every phone, every rocket, every digital screen depends on 0. And yet, for thousands of years, humans counted everything that existed, but had no way to count nothing. That is the mystery. How did the most powerful number in history begin as absolutely nothing? We are taught that 0 is just another number, like 1 or 5 or 9. It feels simple, obvious, almost boring. But here is the truth: for most of human history, 0 did not exist. Great empires rose without it. The pyramids were built without it. Astronomers mapped the stars without it. Human beings were clever enough to build cities and ships and temples. But they had no symbol for nothing. So what changed? Why did humanity suddenly need a way to write emptiness? Who finally solved this puzzle? And why did some cultures fear this new idea for centuries? Tonight, we follow the trail of a strange invention. A symbol for nothing that changed everything. This is the story of 0. Long before 0, humans still needed to count. The first counters did not use paper or ink. They used bones, stones, and simple marks. 1 cut on a bone meant 1 animal. 2 cuts meant 2 animals. It was clear. It worked. As villages grew into cities, counting became more serious. Farmers counted crops. Kings counted soldiers. Traders counted gold. Numbers were no longer small. The ancient Egyptians created symbols for 1, 10, 100, and 1000. The Romans used letters like I, V, and X. These systems were clever. They allowed people to write large numbers. They built roads, temples, and armies with them. But there was a quiet weakness hiding inside these systems. They did not use place value. Today, the position of a number gives it meaning. In 505, the 0 in the middle tells us there are no tens. It holds the place so the other numbers make sense. Early systems had no way to show an empty place. Imagine writing 101 without a 0. How would you show that there are no tens? You couldn't. Not clearly. As numbers grew larger, confusion grew with them. Writing big amounts became long and messy. Calculations became slow and risky. A small mistake could cost a fortune. Counting worked, but only up to a point. And when trade spread across regions, when astronomy demanded exact answers, when empires needed better records, good enough was no longer good enough. If the old way of counting worked for centuries, why did humanity feel the need to change it? As cities grew, numbers had to grow with them. Trade moved across long roads and wide seas. Merchants bought silk, grain, and gold. A small mistake in counting could mean huge loss. Kings collected taxes. They needed exact records. Not close. Not almost right. Exactly. And above them all, astronomers watched the sky. They tracked the sun, the moon, and the planets. One small error could ruin a calendar. This is where the old systems began to crack. Imagine you are a trader trying to write 101 jars of oil. Without a symbol for an empty place, your number could look like 11. 101 and 11 are very different. One is a fortune. The other is almost nothing. When numbers became larger and more complex, confusion became dangerous. Around 300 BCE, the Babylonians faced this problem. They were skilled in math and astronomy. They used a base 6-0 number system, which was advanced for its time. To solve the confusion, they placed a small symbol in the empty space of a number. It acted like a marker. It showed that something was missing in that place. For example, it separated 101 from 11. This was a smart solution. It made numbers clearer. It reduced mistakes. but we must be precise here. This symbol was not zero as we know it. It could not stand alone. You could not add it. You could not subtract it. It was only a space holder, a sign that said, there is nothing here. So here is the deeper question. What turns a simple space holder into a real number? What makes nothing become something you can calculate with? The true turning point did not happen in Babylon. It happened in India. Around the 5th century, a great thinker named Aryabhata worked on astronomy and math. He used a place value system, where the position of a number gave it meaning. This system made math faster and cleaner. But it still needed a clear way to show an empty place. Then came the real breakthrough. In 628 CE, a mathematician named Brahmagupta did something bold. He did not treat zero as just a blank space. He treated it as a number. He gave it rules. He wrote that a number plus zero stays the same. A number minus zero stays the same. A number multiplied by zero becomes zero. This may sound simple to us. But at that time, it was a huge leap. For the first time, nothing could stand on its own. It could be written alone. It could enter an equation. It had power. Zero was no longer just a marker. It had mathematical properties. It could change the result of a calculation. This is the moment zero became real. It moved from being a gap in a number to being a number itself. And once zero became real, math changed forever. But this raises a deeper question. Why did this idea take shape in India? Why here, and not somewhere else? If zero was so powerful, why did the whole world not accept it right away? The answer is simple, but deep. Many people were not afraid of big numbers. They were afraid of nothing. In ancient Greece, the great thinker Aristotle argued that a true void could not exist. He believed nature always filled empty space. To him, nothingness was not real. That idea shaped European thought for centuries. If nothing cannot exist in nature, how can it exist in math? When zero traveled from India through the Islamic world and into Europe, it came with the Hindu-Arabic number system. These numbers were faster and easier than Roman numerals. But many European scholars and merchants did not trust them. They called them foreign. They called them strange. In some medieval cities, these new numbers were even banned from official records. Leaders feared fraud because the symbols were unfamiliar and easy to change. Think about that. The number that represents nothing was seen as dangerous. Not because it destroyed math, but because it changed it. New ideas often face resistance. Even when the data is clear, people hold on to what feels safe. But here is the twist. While Europe hesitated, zero was already growing stronger elsewhere. In other parts of the world, different minds had reached a similar idea. And they did it without ever meeting each other. India was not alone in this story. Across the ocean, in the forests of Central America, the Maya were building great cities. They studied the stars with care and built detailed calendars to track time. And in their calendar system, they used a symbol for zero. It looked like a small shell. It marked the end of one cycle and the start of another. The Maya used zero as a real number in their counting system. They needed it to measure long stretches of time. Without it, their calendar would not work. What makes this so powerful is that the Maya had no contact with India. Different continents. Different languages. Different cultures. Yet they reached the same idea. This is what scholars call convergent evolution of ideas. When separate groups face similar problems, they sometimes create similar solutions. Both India and the Maya needed better math. Both were tracking complex cycles. Both discovered that nothing must be counted. Different worlds. Same breakthrough. So we must ask an important question. Was zero simply invented by chance? Or was it inevitable? When human thinking reaches a certain level, does the idea of nothing always appear? Zero did not spread by accident. It traveled along trade routes, carried by scholars, merchants, and teachers. During the Islamic Golden Age, great centers of learning rose in cities like. Scholars translated Indian texts into Arabic. They studied math, astronomy, and science with deep focus. One of these scholars was Al-Khwarizmi. He wrote books that explained the Hindu number system, including zero. His work made math more organized and easier to teach. In fact, the word algorithm comes from his name. Through these writings, zero moved west. Centuries later, an Italian merchant named Fibonacci learned this number system while traveling in North Africa. In 1202, he wrote a book called *Liber Abaci Star. In it, he showed how much easier trade and accounting became with these new numbers. Roman numerals were slow and clumsy for business. Try multiplying large Roman numbers by hand. It is painful. But with zero and place value, math became smooth. Clean. Efficient. Slowly, merchants switched. Then bankers. Then governments. Roman numerals faded. The Hindu-Arabic system took their place. As zero spread, mathematics began to grow faster than ever before. Algebra expanded. Science gained strength. Navigation improved. Records became precise. Once zero spreads, math accelerates. But even this was not its final form. Its greatest transformation was still waiting, in a world that did not yet exist. Today, zero is more important than ever. Every time you send a message, watch a video, or use a map, zero is working behind the scenes. Modern computers speak a simple language. It has only two symbols, 0 and 1. This is called the binary system. In this system, 1 means there is an electrical signal. 0 means there is no signal. On. Off. Something. Nothing. That is all a computer needs. By combining long strings of zeros and ones, machines can store photos, music, books, and even this video. Every app on your phone, every satellite in space, every AI system is built on this simple pair. Zero is no longer just part of math. It is the foundation of the digital world. Think about that. The symbol that once scared scholars now runs global banks. It guides airplanes. It connects billions of people in seconds. Zero, which means nothing, now controls almost everything. This tells us something powerful. Human progress often depends on simple ideas used in new ways. When we learn to understand absence, we gain control over systems that seem complex. The symbol once feared now powers civilization. But this leads to a deeper question. What does our love of zero say about us? Zero is more than a number. It is a sign of how the human mind works. At first, humans counted what they could see. 1 tree. 2 animals. 10 coins. We counted objects in the real world. But zero is different. You cannot see nothing. You cannot hold it in your hand. To create zero, humans had to imagine absence. They had to give a symbol to something that was not there. This is a major leap in thinking. It means we moved from simple counting to abstract thought. From observing reality to shaping it with ideas. Zero is proof that the human brain does more than react to the world. It builds models of the world. It fills in gaps. It creates systems. It turns silence into meaning. When we invented zero, we did not just improve math. We showed that we can think beyond what is visible. That may be the real invention. Not the symbol itself, but the mental step behind it. The moment we understood that even nothing can have value. We often celebrate inventions that add something to the world. Fire gave us heat. The wheel gave us movement. Electricity gave us light. Each one added power to human life. But zero did something very different. It did not add a new object. It did not create a new tool. Zero gave structure to emptiness. It gave power to absence. It gave meaning to nothing. That is a quiet kind of genius. It teaches us an important lesson. Progress is not only about building more. It is also about understanding deeper. Sometimes the greatest breakthroughs do not come from finding something new. They come from seeing what was always there, and finally giving it a name. Zero reminds us that the human mind is at its best when it dares to think beyond what is visible. From a simple symbol for nothing, we built science, finance, and the digital world. Not bad for a number that means nothing at all. And that may be the most powerful idea of all. Fade out.